Sustainability Council is basically the overseer of all our environmental programs, our greening programs, our academics. And if you look at it in accordance with the triple bottom line, you're looking at everything from the social, economic, and the operational side of the college. So it gets its fingers into everything that we have going on. It provides a service, and it provides the leadership and the direction we need to head. We were at an impasse with our parking with all the traffic jams down here. We looked at the space that we had up there at the Barclay lot, and we were trying to think of what we can really do. We ended up working with the city when we started going for permits. And in dealing with the city, they mentioned the idea about a porous asphalt lot for stormwater management. They caught our interest in that because, again, from the Sustainability Council, it was a way of helping the community and controlling our environment. The way we got involved with Driesinga as far as the porous asphalt lot, was through the city. We couldn't find a lot of firms around town that had in-depth experience with that. I mean, there was a lot of firms, whether they be architectural or engineering, mentioned that they, heard of it and they did a little research on it. Many of them said it was really cost prohibitive. We dealt with a gentleman down there by the name of Arne Larson, and Arne seemed very interested in it. He had some prior experience, and we started working with them.
The whole porous asphalt concept is new. At the time, it was fairly new. There were a few projects around town where they had utilized it. They had some problems, and it was really the city engineer, the stormwater engineer, Randy Lemoyne, who kind of encouraged us to go that way and do something a little bit more green. At the time, the city of Grand Rapids was really starting to push for sustainable sites. On day one, it was something that we, weren't fully prepared to do, but over the course of investigations and some preliminary investigations we did for the school, we became more familiar and confident that, it was the way to go.
We began the project in the spring, and we had to have it completed by mid-August.
Relatively a quick turnaround for the project.
We had to excavate down deeper underneath the asphalt to put a PVC drainage ditch underneath there. It was actually a PVC pipe grid system.
With porous asphalt or with any parking lots, you detain the amount of runoff that you have, and you want to detain such that the amount of water leaving the site after you develop is similar to that before you develop it.
That took the water as it poured through the asphalt, and it collected in cells, and then the cells would release it into a drainage holding tank, and the holding tank would further release it into the Grand River over a controlled system.
The rains fall, it hits the asphalt, it weeps through the holes of the porosity of the asphalt, and then it drops into a stone collection system. The waters then filter into that catch basin, and that's actually the point at which we have an outlet that is piped directly over to the storm sewer system. There were some issues that arose during construction.
When we started digging or excavating, we found that the problem was some old foundations of homes that were there.
It wasn't complete until October, November, because we had some buried foundations to contend with.
The concept of doing the lot as a porous asphalt versus a traditional, the costs were not that much different. We thought they would be a lot greater than what they were.
We found that the porous pavements are actually cheaper system as a whole because you don't put in your storm sewer network. The maintenance element is also reduced. There is still a need to vacuum the asphalt, the porous asphalt. And if you stay on top of the vacuuming, it's really not that much more onerous of the owner to sweep the surface, because typically they're doing seal coats on parking lots, and you drop that program out.
If you can look at this as a positive, I guess, we don't want to have any more parking structures or any more surface lots. What we're actually trying to do is cut back on that. We're trying to promote people riding together, sharing rides from the sustainability aspect. The green roof, that started in about 2008. We were looking at re-roofing. We said, why don't we look into doing a green roof at the Applied Technology Center? We met with some architectural firms, and they in turn started introducing us to different avenues on green roofs or vegetated roofs. We looked at heating and cooling, and we looked at the economical impact that it would have over long term on the building itself.
We began looking at the building that they wanted to put the green roof on, which was the ATC. We began with understanding the major goals of what they were trying to do, what the sustainability committee here at the college was looking for, but then also what the facilities group was looking for a very sustainable long-term roof.
Why did we do it over a traditional roof? Looking at the surroundings of the area, everything was concrete, and we wanted to make it more user-friendly and enhance the environment while still accomplishing what we needed to do as far as roofing.
This building is very interesting in terms of the dynamic nature of the atrium that is all naturally daylit from above. We wanted to also create spaces for students to understand this technology, so we created this concept called the Green Walk, which was a way that students and faculty could get out onto the roof and actually see and experience the roof itself. Part of that was also then cutting windows and openings through that atrium wall.
Our green roof, when we talked about the triple bottom line, that is basically a showpiece because we have built the deck out there, and we currently have students from other universities and colleges using the green roof itself to do experiments. When you look at the price of what a traditional roof versus a green roof was, when we weighed the pros and cons, there wasn't a substantial amount more difference in the dollars that we did have.
Roughly spent about $600,000 on the whole project in total, the lower patio as well as the upper second level roof. The roof membrane that keeps moisture out of the building is protected from the ultraviolet light from the sun, as well as you have this additional thermal barrier, which is the vegetated roof on top of that. So it really adds longevity to that membrane. So they would not have to replace the roof for 50 to 60 years. The plants that we chose were all based on sedum products, which are a drought-tolerant product. It's also a succulent plant, and so the leaves of the plant actually absorb the water, and that's really the key in terms of the water that falls on the roof. The plants automatically want to absorb that water. And if you go up there and you can pluck off a couple of those and just actually kind of squeeze them, you'll feel that water in those leaves. It's actually absorbing the rainwater. So say in a 1-inch rainfall, they're going to absorb probably 95% of that water, and the plants are going to use that then to survive and grow. If we have a large rainfall, the water will go through. The modules are designed such that the water will drain to the drains. But the idea is that we're sending less stormwater to the Grand River. That really is the concept, and we're beautifying and creating this aesthetic beauty on the roof as well.
We don't have measuring devices up there at this time to tell us exactly what we did save and what we didn't save. But we do know, because we have an energy education program going on here at the college, that we have saved a substantial amount.
There are benefits to heating and to cooling systems because we're adding thermal mass to the roof. Hopefully you're seeing maybe some energy savings that you're not doing as much heating or as much cooling in that space, but again, that's hard to tell in an existing building that's 20 years old.
We believe we have saved money. We know our heating and cooling is down in that specific area. We know it acts as sound abatement because we have less noise. I think when you look at the triple bottom line, you're looking at the social, economic, and the environmental concept as we know it. And I think when you're looking at it from the GRCC perspective, we're looking at it more as a community, operational, and an academic standpoint. We're looking at it as far as energy savings. We use desks, we use chairs that are 100% recyclable. All our carpeting goes back for recycling. They recycle everything from the backing to the fibers. We're looking at sustainability with the community and how we can do better things, how we can buy products locally. That's how we're looking at that is, as far as a triple bottom line, it's from the community side, the social, and the economic.